Remove duplicates from sorted list. Given the head of a sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. So we're given a linked list 1, 1, 2 here in example 1, and our output ends up being 1, 2. The reason for this is because we need to delete all duplicates. Okay, so each element can only appear once. And our second constraint is we need to return the linked list sorted. So here we have 2 1s, so we're going to remove this second one, and we're going to get a 1 and a 2. And so it'd be 1, 2, because that's already sorted. Example 2, you might notice that this linked list is also already given sorted. So if we check the constraints here, the problem constraints, let's take a look at this last bullet point. The list is guaranteed to be sorted in ascending order. So we're already given a sorted list, so we're not really going to have to do much sorting, okay, ourselves. Yeah, in example 2 as well, you can see both of these ones condense into 1, 1. And both these 3's condense into a singular 3. Okay. A good way to solve this is simply just using the .next feature that so the definition for a singly linked list here is it has a dot value with an actual integer attached to it, and then it has a .next which references the next node, or the node that it connects to, because this is a singly linked list, so it just connects to one node, right? So basically what we can do is we can just check if the current node's value is the same as the next node's value. If the current node's value is the same as the next node's value, then we can remove the next node. To do this, all we need to do is redirect this current node's arrow to the node 2 after it, right? So if if we find that, so let's say we're starting at the head node, which is given the head, which is, we're always going to be given the first node, starting node, and we find that head.next, which would be this node over here, this second one, is both values are equal, which is true. Then what we can do is we can just take head.next, which is the actual connection, which is the arrow, and set that equal to head.next, which would be this 2 here. So the arrow would go to the 2. Okay, so the arrow would go to the 2. And after we do that, then this 1 would be lost from the list. It would no longer be part of our linked list. So we would get this answer. So let's code that out. Okay. So a good way to iterate through a list as well is to use a dummy. So we can use a dummy, set that equal to head. Okay. So while dummy and dummy.next. Okay. So basically what this does is while dummy and the next node, so dummy.next, are both actually referencing a list node, right? And they're not equal to none, then this loop will continue. The reason why we also have to check dummy.next, the reason that we also have to check that is because we're going to be, in our algorithm, right, we're going to reference the next node. We're going to check if the current value is equal to the next value. So if we're checking if the current value is equal to the next value, then the next node, there has to actually be a node, right? A node has to actually exist next up. So if no node exists, we're going to get an error, right? Because we're not using any sentinel nodes. So we need to check both, okay? If dummy.val is equal to like dummy.next.val, then what we're going to do, right, is dummy.next is equal to dummy.next.next. Otherwise, so the reason we do dummy.next, so on the left side of this equal sign, anything that's on the left side of the equal sign when it comes to these like list nodes, if we do a .next, basically that's referencing the pointer, right? So this dot the pointer that it points to is going to be equal to, and on the right side is the actual node. Okay, so dummy.next.next is the actual node that appears two times after, like 2 places after it, right? Otherwise, the reason we use else is because we don't want to move this forward until we make sure that all duplicates are gone. Since we know that this is already sorted, all of the duplicate nodes would be next to each other. So if I had like a 1, 1, 1 and a 3, 3, and if we remove this first one here, we'd have to stay at this node and make sure that another one isn't there, right? What if there's 3 1s? Like, because this would be deleted and this one would get rolled back here, and we need to check to delete that second one too. So we'd only move forward if we make sure that there's nothing there. So we have to keep checking until it's all gone. So then dummy would be equal to dummy.next, and then we would just return the head finally, because return head returns the entire string. And this is O of n because we're looping through the entire list with dummy and dummy.next, the entire linked list. And the extra space is going to be O of 1 because we are not creating any new structures relative to the input. Okay, thank you.